So in this video, we're going to focus on solving linear equations that contain two of the same variable, and specifically, we're going to be looking at them having the same variable on the same side of the equation. So this means there might be two x's both on the right-hand side of the equation, or two y's on the left-hand side of the equation, and how we solve equations that have a variable appearing multiple times. So when we're solving multi-step linear equations that have variables together on the same side, there are two steps that we want to take to make our lives easier. The first step is we are going to use the distributive property. So we are going to distribute. Now, if you don't remember what the distributive property is, this is when you have something like this, where you have this 3 on the outside here, and then x plus 2 on the inside of the parentheses. And how the distributive property works is you can take the number on the outside and multiply it by each number on the inside. So this becomes 3 times x plus 3 times 2, which becomes 3x plus 6. So if you can distribute in a problem, you want to do that because it will make your life a little bit easier. The second thing you want to do is you want to combine like terms on the same side of the equation. So if you see, after you've distributed, that there are two x's or two y's, you want to combine those together to make the problem easier for you to look at. So those are going to be our first two steps on every problem we do in order to help us to solve equations more effectively and more efficiently. So let's take a look at this first example here. When I look at this problem, there are a couple things that I notice. One is that I have parentheses here. And those parentheses are telling me that I am going to need to use the distributive property at some point in order to get rid of those parentheses. The second thing I see is that I have two x values. So at some point, my goal is going to be to combine those together. So I'm going to start off using what I learned on the previous slide about how I need to distribute first and then combine like terms on the same side of the equation. Now, this problem can be a little tricky with the distributive property because of the way that the negatives are placed. So what I like to do as these problems get more complex is I like to turn my subtractions into additions of a negative number to make things a little more easy. So here, you can turn this into plus -7, and you can even turn this into a plus -4 if you want. You don't have to. Some kids don't like to do that, but I would at least use the keep change right here where the distribution is going to take place. Because the thing that most kids miss is that when we distribute this 7 to hopefully get rid of those parentheses, we actually have to distribute a -7. And we distribute a -7 because it was being subtracted. So here as we distribute, we have 2x, and then we have -7 times x, so we have -7x. And then we have -7 times 3, so it's a -21. So as we distribute, we can see that we are having a -7 times x and a -7 times 3. And as I said, you can use keep change to write those as plus a negative if it's easier for you to see. So now that we've used the distributive property, the second thing we're going to do is we're going to combine like terms. And this is again another instance where using keep change can be helpful. So you could do plus -7 plus -21 and plus -4 if you like, if that makes it easier for you. Doesn't matter. But what we're going to do from here is we're going to look for alike terms. And when you're looking for alike terms, you're looking for terms that have identical variable parts, which means they have the same number of x's, y's, w's, whatever it might be, or no variable at all. Those are also like terms. So here in this problem, what I'm noticing is that I have a 2x and a -7x that are alike. They both have a variable of x. Those can be combined together by simply adding together their coefficients. So we have 2 plus -7, which gives me a -5x. Now, the same thing, here I see -21 and -4. Those don't contain any variable at all, which makes them like terms. -21 plus -4 gives me a 25. Now, one thing I want you to notice is I am only combining things together that are on the same side of the equation. So I was able to combine anything here on the left-hand side together, but notice that the negative 21 and negative 4 couldn't be combined with the negative 60, and that's because they are on opposite sides of the equation. So when you're combining like terms as you're solving, you are only allowed to combine like terms together when they are on the same side of the equation. Then from here, now that we've reached this step in purple where we have a two-step equation, this is an instance where you can now solve the equation using your order of operations or solving equations technique. So if you need to, if you don't remember what to do next, this is where you can list out your order of operations for everything here on the left and undo it in reverse. So this might be an instance where you say, well, there's no parentheses on the left, there's no exponents, but I see a multiplication of negative 5, and I see a subtraction of 25. And you now undo that in reverse. So notice negative 25 and negative 60 can't be combined together because they're on opposite sides of the equation. But you can add 25 to each side. And in doing so, notice how it's a negative 25 and we're undoing it by adding 25. The negative 25 on the left, by adding 25 to it, becomes 0. And on the right-hand side, this becomes a negative 35. Then from here, so we did the adding step, now we can divide by negative 5, and we find x is equal to 7. So just being very careful as you distribute, not missing the distribution of a negative number, and then being very careful as you combine like terms. They can only be on the same side of the equation in order for them to be combined together. So let's take a look at a second example here. So here we can see we have parentheses, so we should automatically already be thinking that the distributive property is going to apply here. And that will hopefully be able to combine some like terms together because we can see multiple x's on the left-hand side. So we're going to focus here on the left-hand side of this problem. Now, there are two tricky things about this particular problem. The first is that there are two distributions, and they are both a little tricky. So you can see one distribution here because there's one set of parentheses here, and there's a second distribution here. And if you're looking at this second example going, I don't see the distribution, that's what makes this second distribution a little tricky. So this first, and now we'll go through that in a second. So this first distribution right here, we are going to take negative 2/5 and we're going to distribute it here to each item. Now, in order to be safe with my negatives, I like to use keep, change, so turn this into plus a negative instead, and in order to hopefully prevent me from making any errors. This one is typically pretty easy for kids to do if they can remember how to do their fractions, so we'll talk about that in a second. The second distribution, if you're thinking there's not a number there, that's what makes this tricky. In math, there are a number of implied things that mathematicians just assume you know are taking place. This is one of them. So when you see a subtraction in front of a parenthesis, but there's no number, they're really implying that there is a 1 there. And in this case, if we use our keep, change, you can make this plus a negative 1. And so really what's happening is you are distributing a negative 1 here. And so you got to be really careful with your negatives. So you saw I put all my keep, changes in there. I wrote all of my subtractions as additions of a negative number, and then I added in this negative 1 right here. So you want to be really careful with your distributions, as it's really easy to miss a negative or miss a distribution if you're not being careful. So now from here, we're actually going to perform our distributions. So this first one here, we have negative 2/5 times 10x. While that might seem like it's a little bit tricky, it's not quite as bad as you think. If you don't remember how to multiply fractions, it's actually quite easy. What you need to do is you need to multiply your two numerators by each other, your two denominators by each other, and simplify. And if you're looking at 10 thinking 10's not a fraction, there's not a numerator and denominator, there actually is. You can turn any integer into a fraction by just putting it over 1. So we can do that. So then from here, we can just multiply across. So this would become negative 20x, because we did negative 2 times 10. And then it becomes 5 in our denominator, because it's 5 over 1, or 5 times 1. And then negative 20 divided by 5 is just a negative 4x. So that distribution wasn't quite as tricky as maybe it seems. Then if we do the next one, we have negative 2/5 times a negative 15. Notice a negative times a negative gives us a positive, so I like to do that right off the bat. Then we do negative 15 over 1. So I already took care of negative times a negative is a positive, so 2 times 15 is 30. Over 5 times 1 is 5. Well, 30 divided by 5 is 6. So that's really not so bad. This turns into negative 4x plus 6. That's that first distribution. So while it looks a little tricky with the fraction, it's really not so bad. The second distribution, we're taking negative 1 times 8, which is going to be a negative 8. And a negative 1 times a negative 2x, a negative times a negative is a positive, and then just 2x. So through our two distributions, this is already looking a lot better. Now again, if you want to continue to use keep, change, change, you can. You can change that 8 into a plus negative 8 if you want, or you can leave it if you don't like to use keep, change, change. That's okay too. So from here, we're now going to combine like terms on the same side of the equation. So what I like to do is put a little line. I can only combine things together on the left and combine things together on the right. So if I look here on the left, I see there's a negative 4x and a positive 2x. Those combine together, if I add their coefficients, to be a negative 2x. And then I see a positive 6 and a negative 8. Those combine together to be a negative 2. That equals negative 4. Now from here, how you solve this portion is going to vary depending on how you best solve equations. If you need your order of operations trick, that's where you can make your order of operations list over here and say, okay, there's no parentheses, no exponents, multiplication and division. I see that I'm multiplying by negative 2, nothing else. And then addition and subtraction, I can see that I'm subtracting 2. So you can undo that in reverse. So we start by adding 2 to each side. So we have negative 2x is equal to negative 2. Divided by negative 2 gives us x is equal to 1. And if you're unsure if that's right, you can take this x value of 1. You can take that value and you can plug it back into where all the x's are and test to see if it makes that equation true.